The midsegment of a triangle is a segment that joins midpoints of two sides of a triangle. This means every triangle has three midsegments. So given P, Q, and R are midpoints of the sides of triangle ABC, so AP equals PC, AQ equals QB, and CR equals RB. The three midsegments of AB are shown. So we have one connecting these two midpoints, one connecting these two midpoints, and one connecting these two midpoints. Theorem. The midsegment of a triangle joins the midpoints of two sides of a triangle and is parallel to and half as long as the third side. Given that AP is congruent to PC and AQ is congruent to QB, prove that PQ is parallel to CB and PQ equals 0.5 CB. So the length of PQ equals half the length of CB. Note, this theorem was covered in an earlier unit. However, we will use theorems from this unit to prove the theorem now. Alright, so given AP equals PC, so this portion is congruent to this portion here, and AQ is congruent to QB, prove that PQ is parallel to CB. So we want to prove that this line here is parallel to this line here. So we start with our given information. Then we're going to construct another line here. We're going to extend the line PQ over to the point R so that PQ equals QR. So this segment here is congruent to this segment here. Next, we're going to draw line RB between points R and B. And why can we do that? Well, because of the line postulate. Between any 2 points, you can draw a line. All right, so we've drawn RB here. So what step is missing here that would have the reason vertical angles are congruent? Where are there vertical angles here? Here and here. So this angle is congruent to this angle. Okay, so since AQ is congruent to QB, and these angles here are congruent because they're vertical angles, and PQ is congruent to QR, these two triangles are congruent because of side angle side triangle congruence. Alright, so because corresponding parts of congruent triangles are congruent, we know that AP is congruent to RB, and we also know that angle A is congruent to this angle here. Since angle A is congruent to angle QBR, that means that this line here is parallel to this line here, since these would be alternate interior angles. Since AP is congruent to PC, and AP is also congruent to RB, that means that PC is congruent to RB because of the transitive property of congruence. Since these opposite sides here and here are parallel and congruent, that means that PRBC is a parallelogram. Since PRBC is a parallelogram, we know that the sides PQ and CB are also parallel because that's the definition of a parallelogram. Alright, so we have shown that PQ is parallel to CB and the length of PQ equals 1/2 the length of CB. To prove the second part is trivial, since triangle AQP is congruent to triangle BQR and PRBC is a parallelogram. See the diagram for explanation. The midsegment of a trapezoid is the segment that joins the midpoints of the two non-parallel sides of a trapezoid. So a trapezoid has only one midsegment. P and Q are midpoints, so AP is equal to PD and BQ is equal to QC. Click on the link below and complete the lab. Theorem. The midsegment of a trapezoid is parallel to the bases and its length is the average of the bases. Given that AB is parallel to CD and P and Q are midpoints, so AP equals PD and BQ equals QC, prove that AB is parallel to PQ and the length of PQ equals the average of the bases, AB plus CD divided by 2. Before turning to the next slide, what is the best strategy for proving this theorem? Alright, so if we draw this diagonal through the trapezoid from this point to this point, we have the triangle midsegment theorem twice on side-by-side triangles. We have it once here and once here. The figure to the left serves as the proof.